Let's take a look at composition and inverse functions, how to compose new functions from existing functions, and then there is this other concept of an inverse function. So today we'll be composing two functions. We'll be identifying what a function is and whether it is a function or not, by the way. Also, we're going to learn how to find an inverse and also how to check that two functions are inverses. We call that verifying inverses. So let's talk a little bit about function notation. You probably know this, but function notation is where you give the function a name and then you put two parentheses, and in here is where you put your independent variable. Now this is pronounced f of x, f of x, f of x, and that just means we have a function f where we put numbers in usually where that x is. And then you could have other functions. You could have g of x or h of x or all kinds. You could even have like h of t. It doesn't have to be x. Now composition is where we're going to take one function and we're going to put another on the inside of it. So this would be pronounced f of g of x, f of g of x. There's a second way to write it, however. We write f composed of, with a little circle like that, g. Okay, and then we put parentheses around that. So that's f composed of g, and then we put parentheses here to show where the independent variable is. So those two things are the same thing. I generally like this notation better because to me it's where you see that g function nested inside the f function. But a lot of textbooks and exercises will show this notation as well. So I know it looks like fog, but it's f composed of g, where x is the independent variable where we put things. So if you look down below here, we have a couple functions, and that's one of the advantages of function notation is that you can give them names like f and g, and we know exactly where to look. So for example, if I asked you to find f of 2, you would know to put 2 in for x here. That would be 12 minus 4, which is 8. However, if I told you to find if I were to tell you to find g of, let's say, 3, you would know to go over here and look over here, right? So if you put 3 into that, you're going to get negative 18. So that's why we give these names. Okay, so what's going on the left side here, right here, is that we're going to put g inside f, because remember, this is the same thing as writing f of g of x. And I often like to color code it, at least when I'm initially teaching this, to show students how this works. So what does the f function do? Think of it as a machine, right? Here's the machine. The f function is 3 times the input squared minus 4. That's what the f function does. Now inside here, we're going to put g of x. We're going to put the entire function in there. So we'll put negative 2x squared in there. And then we're just going to simplify this out. So this is 3 times 4x to the 4th minus 4. So that's 12x to the 4th minus 4. And that would be our composition of two functions. This is called composing a new function from two existing functions. Now, vice versa over here on the right, we're going to go backwards now. We're going to take our g function and we're going to put f inside the g function. So let's do that. We'll start with the g function is negative 2 times the input squared. That's what this says that the g function does. And inside there, we're going to put 3x squared minus 4. And then we could leave our answer like that, but let me go ahead and simplify this out a bit. Remember, this ends up being a FOIL question, by the way, 3x squared minus 4 times 3x squared minus 4. So we get a middle term. This is going to be negative 2 times the quantity 9x to the 4th minus 24x squared plus 16. And then you could double everything and multiply by the negative. So negative 18x to the 4th plus 48x squared plus, minus 6, boy, I'm on a roll here, 32. There we go, 32. So that would be g of f of x right there. Notice that they're different. We did, on the left side of the screen there, we did f of g and we got this. Over here we did g of f and we got something completely different. So it does matter which one you do first. Okay, let's do this next one. This one's actually a little simpler. Maybe this one should have been first. There's no squares in it, so it works out a little nicer. You might want to pause the video and see if you can figure out f of g and then g of f, and then you can check your work. All right, so this first one is f of g of x. So the red function, it's called the outside function here, is our f of x. So that is input plus 3. And what we're putting in is the g function, which I wanted to put a blue box around. That's 2x minus 7. So this would be 2x minus 4. That is f composed of g of x right there. Okay, that's the answer. Now on the right side of the screen we have the g function. We're going to put f of x inside the g of x function. So here we go. The g function is 2 times the input minus 7, and I'm putting x plus 3 in there. There's no squaring this time like there was on the last one, so this is nice. We get 2x plus 6 minus 7. That equals 2x minus 1. That's g composed of f of x. Right there, there's the answer. Okay, so now you know how to compose two functions. So let's roll back a little bit and make sure we remember what a function is. A function is a one-to-one relationship between two variables. So sometimes we do like these kinds of charts where we say, okay, if I put 1 into the machine, into the function, maybe I get 2 out. And every time I put 1 in, 2 comes out. All right, and then I put 3 in, and I get 5. So every time I put 3 in, I put 5. And then maybe I put 6 into the machine, and I get 5 out again, and that's okay. That's still one-to-one. All right, the outputs are allowed to repeat, but the inputs cannot repeat and get different answers. You can imagine if I went back and plugged 1 in and then I got 3 out, that would seem like we have a broken machine. It's no longer a function. It's not one-to-one if that happens. So it has to be a one-to-one relationship. All right, so what is one-to-one? Every x maps to exactly 1 and only 1 y value or output. Every input maps to only 1 output. You see over here, every input, 3 maps to 5. That's a one-to-one. 6 always maps to 5. That's one-to-one. So this is a mapping diagram for a function. So every function is one-to-one. Now, graphically speaking, we can have a graph of our function. I'll draw a little parabola here. This is a function because it passes what's called the vertical line test. The vertical line test says if you can draw a line, and then if you imagine moving that line all around here, if it only hits once everywhere, then it's a one-to-one relationship. You see how this x down here maps to this y over here always and only one time? That x only maps to one y value. So we're okay. This is one-to-one. That passes the vertical line test, so this is a function because it passes the test. So what does it look like when it fails? Well, we could have a parabola on its side actually, and you can see if I draw a vertical line here, I see it hits twice. So it fails the test, and so it's not a function. Okay, so that's how we can spot it. All right, there's also a horizontal line test, and it's basically the same. We're going to see what this is useful for here in a moment. But if I have a graph like this, you see how that passes the horizontal line test. And that's going to have to do with the inverse, which we'll talk about in a bit here in this video. All right, state whether the following are functions. Are they one-to-one? So x to the fifth, if you go to your calculator, your graphing calculator, or maybe Desmos, and you put this in, you're going to see that it looks like this. And indeed, that is one-to-one. Everywhere I draw a vertical line, it only hits once, so yes. Okay, this is a yes. Now what about this one over here? This one's kind of crazy. However, if you go and graph it, I'm not sure exactly what it looks like, but it might look something like this, okay? But it will pass the vertical line test. These vertical lines only hit once, and so yes, this is also a function. All right, so the second part of this video is going to be discussing the concept of an inverse. An inverse function, it is a way to undo or reverse another function. So imagine this. Imagine, if you will, that we start with the number 3, and then I say, hey, let's square it. Okay, so we're going to use the function x squared, and we get a 9. Okay, and then I say, oh, wait, I didn't want to do that. How do we undo that? What is the opposite of squaring? What is the reverse? What is the inverse of squaring? Well, you all know what it is, right? It's just a square root. You understand we're just going to square root that 9, and what do we get? We get right back where we started. It undoes the square. So those are called inverse functions. So we started with a 3, we turned it into a 9 by squaring it. We said, oh shoot, let's undo that. So then we did the square root of 9. We're right back where we started. So that's the concept of an inverse, is they undo one another. And it has this fancy notation you see right here. It looks like an exponent of -1, but it's really not an exponent. We pronounce that the inverse of f, the inverse of f. So let's look at this example here. If f of 2, okay, if 2 goes in and out, if 2 goes in and then out comes -5, what has to happen on the inverse? Think about what I said over here. What has to happen on the inverse? A 3 turned into a 9, and then I needed to undo it, so a 9 needed to turn back into a 3. The answer would be, on the inverse function, a -5 needs to turn into a 2. Okay, the input of -5 needs to turn into a 2 output. So that's what that means. It's kind of neat. And so by the way, up here, you see a function 3x minus 11, and that's, I think, the function I was using here. But so, you know, if you plug -5 in here, that doesn't work. Okay, this is the original function, so you would plug 2 in right there, and you get -5. Now I'm going to show you in a moment how to find an inverse function, because it's not just 3x plus 11. Some students think it's just 3x plus 11, but it's a little bit different. Verifying functions as inverses. So how do we check to see that two functions actually do undo one another? All right, there's two different ways. The algebraic check is that you take f of g of x, okay, and it needs to simplify to x, and you also need to check that the other way around, if you put g of f of x and you work it all out, it will simplify to simply the number that you start with, which we're calling x. So down here, we're going to do a problem here in a moment where it says, verify that these two are inverses. You see how I gave you f and I gave you g. All right, this says verify because they are inverses, by the way. It wants you to check. It wants you to check that they are, or confirm that they are. And we're going to do f of g and g of f here in a second. The other way that's kind of neat to check is graphically, and I really always enjoy this. this concept is that if you have a function f, its inverse will be a mirrored image across y equals x. It's called symmetry. It will be symmetric over here on the right side, so it's going to be like this, and it's going to be a parabola on its side. Okay, so this would be the inverse function. So they're symmetric across a 45-degree angle line. Every point right here goes straight across, and you've got what I like to call the sister points over here, all at a 90-degree across that central line. So that's how you can graphically check that two things are inverses. And if you think about it, it makes a lot of sense, because over here, let's imagine that this point is negative 2, 5. Okay? So what has to happen on the inverse? What has to happen? Remember, right here, this would be 5 needs to turn into a negative 2. They switch places. The x's and y's switch places. Okay, so let's do our verification. So make sure you understand what's going on here. So when the directions say verify, this is what you do, folks. We're gonna do two parts. Okay, we're gonna check that f of g of x, we expect that to be x when we get done. All right, we expect it to be x. That's how we're going to verify it. So the f function is 3 times the input plus 4, and then we're putting the g function on the inside. So I know these are fractions and it might look scary, but when you do the distributive property here, you just get x minus 4. And then we have the plus 4. And those guys add up to 0. Look at that. It does equal x. So we put a check mark. We just confirmed that that works. So that's part 1. So this is number 1 over here. Number 2 is where we now do it the other way around, g of f of x. So we're going to take our g function, which is 1/3 times the input minus 4/3. And we're going to simplify that a bit. So if you do the distributive property, 1/3 times 3 is just x, and then we get plus 4/3, and then we have minus 4/3. Well, what do you know? Those two just add up to 0. We get plain old x. We put a check mark there. We have just confirmed that f of g and g of f, both of these, give x in the end. So that goes back to my explanation up here, is that we have come full circle. We started with x and we ended with x. That's what that means. Every single generic x. So that's how you verify. That's how you verify. So I'm not going to do 1,000 of these for you because it's really not hard. You do f of g, g of f, and if you do the algebra right, it indeed will come out to be x. If it doesn't come out to be x, you probably did something wrong. Now let's take a look at how to find these inverses. Like if you're given an f, how do you figure out the inverses? Like who came up with this? How did they figure this out? If we were given this function, how do we get the inverse? Okay, and it's really pretty simple. You just have to do a few of these. Is you switch x and y, switch x and y, then solve for y. That's all it is. Now you might say, I don't see a y in this, right? But this is the y to begin with, okay? That's what y is. So then if we're going to switch, so in your notes I'd write the word switch, x equals negative 2y minus 7. Notice the signs are still the same. None of the signs changed. It was only the x and the y switched locations. Why are they switching locations? Right here, remember? X and y, y and x. They switch location on the inverse. That's why we're doing it, folks. That's why the algebra works here. We now solve for y, so we just add 7 on both sides. X plus 7 equals negative 2y. Divide by negative 2, divide by negative 2. We have our answer. It is negative 1/2 x minus 7/2 if you want to write it in y equals mx plus b format if you were asked to graph it. Switch x and y, solve for y, and boom, you've got your inverse function. Remember, the inverse function gets written with that little negative 1 up top. So that's how you find inverses. All right, so let's spiral back to the beginning here. Today, in this video, hopefully you learned how to put two functions together. We talked about a one-to-one relationship on a function. All right, I just showed you how to find an inverse. You switch x and y, solve for y. And then I also showed you how to verify. You do f of g and g of f, and they should both come out to be x. All right, well, hopefully this was helpful, and good luck on your assignment. Until next time.